Hope you've enjoyed your snow day. Today we're going to look at some theorems and write down some theorems in our notebook. You may need to pause the video at certain times so you have enough time to copy everything down. I'm going to talk a little bit fast in this video, but you can always rewind and listen to it again. Our learning target today is I can prove theorems about lines and angles. I also can prove theorems about triangles. We're not going to do them all today, we're just going to do a few. I want to remind you that when we're writing a proof, we can use definitions, we can use properties of algebra, we can use theorems that we've already proven as well, but not until we've proven them. And in order to write proofs, we're going to need to build a database of facts. And our interactive notebook is where we're going to keep that. So if you'll have a section in the back where you write down your proofs and your theorems so you can study through them, not have to look back through everything, so that you can revisit them each night until you definitely know them. Some properties that you're going to need for today for the proofs that we're doing is the transitive property. Transitive property says if A equals B and B equals C, then A equals C. The transitive property works for equality and congruence. So it could have said A is congruent to B and B is congruent to C, so A is congruent to C. Symmetric property says A equals B, so B equals A, and that also works for congruence. So if A is congruent to B, then B is congruent to A. That makes it so we can just flip the sides around. The commutative property says that I can switch the order for addition, and it won't change the answer. See here I switched A and B and B and A. I'm still adding the same numbers together. I'll still get the same result. The commutative property says that I can change the order, and that also works for multiplication. Those are properties from algebra, so we're going a little bit fast there. Before we get into this next part about parallel lines, we first need to get familiar with the names of angles. You did this in middle school at one point. Corresponding angles are on the same transversal but on different lines. They're in corresponding locations. So angle 2 and angle 6 are corresponding angles. 4 and 8 are corresponding. 1 and 5 are corresponding, and 3 and 7 are corresponding angles. So I'm going to write down one set. But remember, this is not the only set. I'm just going to write down one set. It takes me a little bit of time to write them down. Sorry about the handwriting here. Alternate interior angles are on alternate sides of the transversal. N is your transversal. So 4 and 5 are alternate interior because they're on the inside of those two lines, L and M. So 3 and 6, sorry. 3 and 6 and 4 and 5 are alternate interior. So I'm going to write down 4 and 5, but it's also alternate interior are 3 and 6. Now alternate exterior are 1 and 8 and 2 and 7. Alternate exterior is what it sounds like. Exterior, outside of the lines. Alternate sides of the transversal, so 1 and 8, 2 and 7. Consecutive, one right after the other. Interior, so one angle right after the other on the interior of the angles, 3 and 5, or 4 and 6. Those are also referred to as same side interior angles. Now, vertical angles and linear pairs, we went over those yesterday, and they don't really have anything to do with the lines being parallel. They're true regardless of that. Vertical angles are opposite each other. Angle 1 and angle 4, they're on the same, on intersecting lines in opposite locations. So angle 1 and angle 4. But there's a lot of other pairs of vertical angles up there. 2 and 3 are vertical angles, and we know vertical angles are congruent. 5 and 8 are vertical angles, and 6 and 7 are. So 1 and 4. And vertical angles are congruent. It doesn't have anything to do with parallel lines. If you have vertical angles, they're on the same line, same set of intersecting lines on opposite sides of vertical angles. Now, a linear pair, notice it has line in it. They make a line when they're together. 1 and 2 are a linear pair. That means they're supplementary. And we went over the linear pair postulate the other day. So if you have two angles that make a line, then you have a linear pair. And they are supplementary. Because remember, a straight angle is 180. So we have lots of pairs of linear pairs here. 2 and 4 are a linear pair. 4 and 3 are a linear pair. 3 and 1 are a linear pair. 7 and 8 are a linear pair. 8 and 6 are a linear pair. And you could name another set. Now we're going to go ahead and get into the next part. We're going to prove, first we get one postulate about parallel lines. If parallel lines are cut by a transversal, so the transversal is a line that intersects 2 or more lines. If you have 2 parallel lines cut by a transversal, then corresponding angles are congruent. Corresponding angles are these 2 angles marked in red. Those are not the only ones. Remember, the ones below those 2 are as well, and you have 2 more pair on the other side. But corresponding angles are congruent, and that's a postulate, so that means you don't have to prove it. It's accepted without any proof.